What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 2, Section 6, Other Types of Equations. Let's do it. In a radical equation, what does it mean if a number is an extraneous solution? So oftentimes when you're solving a radical equation, you're going to get two solutions. In some cases, one of those solutions will be what we call extraneous, meaning if we plug it back into the original equation, it actually won't be a viable solution. This will make a lot more sense as we go through some examples in later problems. Your friend tries to calculate the value of -9 to the 3/2 power and keeps getting an error message. What mistake is he or she probably making? So my assumption is you're seeing this -9 here and then you're seeing the exponent. So my assumption is in the calculator, you're trying to take -9 to the 3/2 power, when in fact, when the minus sign is in front, you're actually doing 9 to the 3/2 power, and then you're sticking the negative on at the end because it's not in parentheses. So if I were to do this myself by hand, this is the same as taking the square root of 9 and then taking that value and cubing it. So if I take the square root of 9, that's 3, and then 3 cubed is 27, and then we stick that minus sign on at the end to get the answer. Boom, done. Explain how to change a rational exponent into the correct radical expression. So it's very important to remember, let's say I have x to the 3/5 power, that there's a simple relationship in terms of the rational exponent converting back to radical format. The top is the power, and the denominator is the root or radical. So for example, when it's to the 3/5, this means we're taking x to the 3rd power and then the 5th root of that result. We can also write this and it'd be the exact same result. This is no different. I could also write it as the 5th root of x and then that entire value cubed. These will give you the same answer. Boom, done. To solve this equation, what I'm going to do is I'm going to raise both sides to the reciprocal of 3/4. Okay, so if I raise to the reciprocal of that, which is 4/3, and then I also raise this side to the 4/3 power, I'll get an answer for x. The reason why is if I raise it here, these guys actually multiply. So 3/4 times its reciprocal, or any fraction times its reciprocal, is just going to be 1, right? You'll get 12/12. So this simply becomes x. Now I want to take 27 to the 4/3 power. That's the same as, again, taking the cube root of 27, because that's the denominator, and then taking this to the 4th power. And I like to do the radical first because then I want to go small first before multiplying it out. Otherwise, if you take 27 to the 4th power, that's a huge number. Finding the cube root is pretty difficult. So the cube root of 27 is actually 3, because this is asking what number times itself again is 27. That's 3. And then last but not least, 3 to the 4th power. That's 3 times 3 times 3 times 3, which is 81. Boom. So I'm going to start once again by raising both sides to the reciprocal of 3/4, which is 4/3. So check this out. I'm going to do this one to the 4/3 power, and I'm also going to take 8 to the 4/3 power. So these two are going to cancel out when they multiply turns to 1, and I get x minus 1 equals 8 to the 4/3 power. But I'm going to save a step here, and I'm going to actually convert it back to radical format. So I'm taking the cubic root, because that's the denominator, of 8, and I'm taking the result of that to the exponent of the 4, or 4th power. So the cubic root of 8 is actually 2. 2 times 2 times 2 is 8, and then we have 2 to the 4th power equals x minus 1. 2 to the 4th power is, of course, 2 times 2 times 2 times 2, which is 16, equals x minus 1. Last but not least, let's add 1 to both sides. Boom, boom, and I get x equals 17. Done. Here we've got a quadratic in disguise. So watch what I'm going to do. I'm going to essentially go like this. I'm going to set it up to factor. And what is going to be in the beginning? Well, it's x to the 2/3 power. That means I'm going to have x to the 1/3 here and here. Because remember, when we multiply, we add the exponent. So that would give us our x to the 2/3. And then over here, we've got what multiplies to +6 and adds to -5. That's -2 and -3. You can see that's going to give us that nice x to the 1/3 power for the middle term, and so we're good to go. So these are our two solutions. Our two solutions are x to the 1/3. When is that going to equal to 2? Because when this equals 2, it's going to zero this part out. Likewise, my other solution is going to be when x to the 1/3 equals 3, because when this is 3, it's going to 0 out as well. Now we're going to solve both of these. So I'm going to raise both sides to the third power. Again, that's the reciprocal of 1/3. So that's going to just cancel out to x, and 2 to the third power is 8. Likewise, I'm going to do the same thing here. Cube both sides. That's going to cancel out to 1, and we have x equals 3 to the third power, which is 27. So here are your answers. Boom. For the following exercises, solve by grouping and factoring. So the way we group, and this is a nice indication that we should group, is if there are 4 terms, and it's pretty straightforward. We basically just group these 2 guys together and group these 2 guys together. It's not multiplying, so I don't want you to think I'm multiplying them because how close the parentheses are. That's just how we're going to break it up. And we want to keep that minus sign within the group. Now what I'm going to do is I'm going to look at this first pair of terms. I'm going to factor out the GCF, which is x squared. And I'm going to have x plus 2 left inside, right? Because if I redistribute it, I get the x cubed and 2x squared. For this one, I can factor out a minus, and really like a -1, so I'll even put that there. If I factor out a -1, I'm going to get an x plus 2. Now, this is the key. We want the same binomial here and here. And these are special problems where they're set up specifically so you can factor successfully by grouping. Now I got this equal to 0. So now I've got an x plus 2 and an x plus 2. I can factor those out from each of those terms, put one x plus 2 in the front, and then I have that x squared minus 1 left over. And I can factor this part again. It's a difference of squares. So I can make it x plus 2 times x minus 1 x plus 1. That's how we factor a difference of squares equals 0. So I've got 3 solutions here. I've got when this goes to 0, which is -2. I've got when this goes to 0, when x equals 1. And when this goes to 0, when x equals -1. Boom, done. So this one I'm going to factor out a GCF, which is y. So I've got y on the outside, and then I've got 4y squared minus 9 equals 0. And check this out. This is a difference of squares. So I can factor this nicely as the square root of 4y squared, which is 2y here, square root of 9, which is 3 here, and then we got the plus and the minus, and now I can get my 3 solutions. So again, it's when this is equal to 0. So when does just the y equal 0? When it's equal to 0. When is this going to equal 0? Well, you can set 2y plus 3 equal to 0, or you can kind of see it's this term over that term and negated. And you see if you plug in -3/2, it'll 0 out this binomial. Last but not least, what's going to make this one go to 0? Again, it's -3/2 negated, which is +3/2. If you plug that back in, you'll see that will 0 out this binomial. So here are my 3 solutions. Boom, done. Once again, we're factoring by grouping, so I'm going to factor the first 2 terms and the second 2 terms, so we're going to group them like that. What's the GCF of these guys? It's going to be m squared, left with m plus 1 in parentheses. You can see if I redistribute, I'll get m cubed plus m squared. That's how we know we did it correctly. Out of here, we're going to factor out a -1, and that's going to leave an m plus 1 inside. And this is what we want, the same binomials. Now I can factor out m plus 1 from each, like so. And what's left inside is that term right there, m squared, and the -1. And then you can see this is a nice difference of squares, so it factors to m plus, well, this is just m plus 1. This factors to m plus 1, m minus 1, and all of this still equals 0. So my solutions will be when each of these binomials goes to 0. For these 2, it's going to be the same, -1. And for this one, it's going to be +1. Those are the 2 solutions for m. Boom, done. First, in this one, I'm going to set everything equal to 0. So I'm going to get 5x cubed minus 2x squared. You see I'm subtracting that from both sides, and then I'm putting it next to the 5x cubed because I like to go in descending order in terms of these exponents. Then that 45x can stay put, and then I have to minus 18 from both sides, and then I got all of this equal to 0. Now we're going to factor by grouping these guys and these guys. My GCF here is going to be x squared, and that's going to leave a 5x, right? If I redistribute, I get that 5x cubed. And then minus 2, which would, again, multiply the x squared and give us that minus 2x squared. Here, I've got a GCF of 9 for both terms, +9. That gives me 5x, right? 9 times 5x puts me back at the 45x. And then factor 9 out of the 18, and I'm left with 2. And we know it's done perfectly because we got the same binomial here and here. So now we can factor out the 5x minus 2 from both sides, and Then what do we have left? We have an x squared and a positive 9 equals 0. So for this binomial, we've got a nice solution. We take this over this and negate it. So negative 2 over 5, which becomes positive 2/5. Okay, now what about this? This is a sum of squares. This is actually not factorable, and there's not a real number solution, because to get x squared plus 9 to equal 0, you can't square a number and get a negative, but we can get the complex solution or imaginary solution. So I'm going to subtract both sides by 9. I get x squared equals negative 9. I'm going to take the square root of both sides, and I get x equals plus or minus. Now, the square root of negative 9, that's actually 3i, okay? You can take the square root of 9, which is 3, and the square root of negative 1, which is I, if you want to break it down that way. So now we have a solution of 2/5, positive and negative 3i. Boom, done. For this one, we're going to start by getting rid of the square root. So we have this expression under the square root. To get rid of that, we're going to square both sides, right? Because if we square a square root, we're kind of doing the opposite operation, and it goes away. So now we have x minus 7 equals 5 squared, and 5 squared is, of course, 25. Last but not least, we're going to add 7 to both sides. Boom, and we get x equals 32. Now we want to check and make sure this is a valid solution. So we plug this 32 back into the original equation. 32 minus 7 is, of course, 25. Square root of 25 is 5. 32 is the winner. Done. So to solve this problem, again, we're going to start by squaring both sides. That way we get rid of that square root. We're doing the inverse operation of taking the square root. So we square both sides. That removes the square root symbol. Now we have 3t plus 5 equals 7 squared, and 7 squared is, of course, 49. Now we're going to isolate. We're going to subtract 5 from both sides. Boom, boom. 3t equals 44. Last but not least, we're going to divide by 3. Boom, and our answer is 44 thirds. Boom, done. Here, once again, we're going to start by squaring both sides. That's going to get rid of that square root symbol. So now we have 12 minus x equals x squared, and you'll notice now we have a quadratic equation. So we're going to set everything equal to 0 and then solve. So I basically subtracted 12 from both sides, I added x to both sides, I just flipped it to the left side, but now we have x squared plus x minus 12, and now we're going to factor. So the question is, what multiplies to negative 12 and adds to positive 1? That's going to be positive 4 and negative 3. And this gives us two solutions, right? What zeros this out and what zeros this out? That's going to be negative 4 and positive 3. But now we have to check to see if there's an extraneous solution in this case, right? So we're going to plug both of these back in to the original equation and see if they're legitimate. So first, if I plug negative 4 in, I get 12 minus negative 4, square root of that, equals negative 4. So this becomes a plus, that becomes 16. Now, we're looking at only the positive roots in these cases to figure out if something's extraneous. So the square root of 16 is positive 4, which does not equal negative 4, which means negative 4 is an extraneous solution. What about if we plug in 3? So now let's replace this with 3. We got 12 minus 3 equals 3. Square root of that, of course, and then 12 minus 3 is 9. So the square root of 9 is 3, because again, we're taking that positive root. 3 is a legitimate solution. Boom, done. So this problem is pretty complicated. You can do it in multiple ways. I'm going to opt to move the square root of x plus 2 to the left side and then solve. So you see I've subtracted the square root of x plus 2 from both sides. Now what I'm going to do is I'm going to square both sides, okay? Because that's the only way we're going to get rid of the square root. And we're going to have to do this 2 times. So first I square both sides, and I get 3x plus 7 equals. Now this is going to FOIL. You don't just square these individually. So for example, it's really going to be 1 minus square root of x plus 2 times itself. 1 minus square root of x plus 2. So as we FOIL this, 1 times 1 is 1. Then we do minus square root of x plus 2. And then again, this is going to get another minus square root of x plus 2. So we're going to get minus 2 square root of x plus 2. And then these guys multiply against each other, and it sort of removes the square root. So we get plus, right? The minuses cancel out when you multiply, plus x plus 2. Now I'm going to combine like terms quickly on the right side. So I'm going to combine the 1 and the 2. So I get 3x plus 7 equals negative 2 root x plus 2 plus x plus 3. Now we're going to isolate the radical. So I'm going to move everything but the radical to the left side. So I'm going to subtract x from both sides. Boom. And I'm also going to subtract 3 from both sides. Boom. So now I get negative 2 square root of x plus 2 equals, and then 3x minus x is 2x, 7 minus 3 is 4. And then last but not least, I'm going to divide both sides by negative 2. So that's going to give me negative x minus 2 equals radical x plus 2. Once again, we got to get rid of that square root, so I'm going to square both sides like so. So when I square the right side, of course, that's just going to become x plus 2. And if I square the left side, I have to FOIL this, right? So it's negative x minus 2 times negative x minus 2. So as I FOIL these two, I go boom, those guys multiply, and I get x squared. Then that becomes negative x times negative 2 is positive 2x. That's another positive 2x. That's going to make 4x. And then last but not least, negative 2 times negative 2 is positive 4. Okay, now I got a quadratic, so I'm going to set everything equal to 0. So I got x squared. If I subtract x from both sides, I get 3x. Subtract 2 from both sides, I get plus 2 equals 0. Now we'll factor. And the question is, what multiplies to 2 and adds to 3? That's going to be positive 1 and positive 2. So the two solutions are going to be what zeros this out and this out. And that's going to be negative 1 and negative 2. Now we have to check to make sure these are legitimate or see if they are potentially extraneous. So here I'm going to plug negative 1 into the original equation. So negative 1 times 3 is negative 3 plus 7. That is 4. Plus negative 1 plus 2 is 1 equals 1. This is not legitimate because, once again, square root of 4 is going to be 2. Square root of 1 is going to be 1 because we're taking the positive root. 2 plus 1 does not equal 1. So negative 1 is extraneous. Now let's check negative 2. So negative 2 times 3 is negative 6 plus 7 is 1. And then negative 2 plus 2 is 0. So square root of 1, does that equal 1? Yes, it does, because the square root of 1, here we're taking the positive root. That's 1. 1 equals 1. Negative 2 is legitimate. Boom, done. For the following exercises, solve the equation involving absolute value. So what we're going to do here is we're actually going to start by splitting this into two different equations. So the first one is going to be with the absolute value bars removed, and the second one, we're also going to have them removed, but in the second one, we negate what's outside of the absolute value. Because remember, when it's absolute value, it means that, yeah, this could also equal negative 8, and it will still solve the equation, because absolute value bars are the positive purifiers. Whatever is in them, it comes out positive. Now we got two equations, so we'll solve them. So first I'm going to add 4 to both sides like so. Boom, 3x equals 12, divide by 3. And one of our answers is x equals 4. For this one, I'm going to add 4 to both sides like so. Boom, boom. And then we're going to divide by 3. And we get negative 4/3. So my answers are x equals 4 or x equals negative 4/3. Done. So before we can solve this one, we want to isolate that absolute value. So first I'm going to add 1 to both sides. Now I can split it into two equations. So first I have 1 minus 4x equals positive 6 and 1 minus 4x equals negative 6. Again, we're in the second equation, we're negating the other side, the stuff outside the absolute value. Now I'm going to subtract 1 from both sides. Boom, boom. And I get negative 4x equals 5, divide by negative 4, and there's one of our answers. It's negative 5/4. The other one, I'm going to subtract 1 from both sides like so. Negative 4x equals negative 6 minus 1 is negative 7. Divide by negative 4, and we get 7/4 because the negatives cancel out. So my two solutions are negative 5/4 and positive 7/4. Boom. Once again, we're going to start by isolating this absolute value. So first I'm going to add 7 to both sides. So now I get absolute value of 2x minus 1 equals 5. And now we're going to split. So we're going to say 2x minus 1 equals positive 5. 2x minus 1 equals negative 5. And then we're going to solve these two equations. So I'm going to add 1 to both sides here. 2x equals 6. Divide by 2. And we get x equals 3. And then for this one, we're going to add 1 to both sides. Boom, we get 2x equals negative 5 plus 1 is negative 4. Dividing both sides by 2, and we get x equals negative 2. So 3 and negative 2 are my solutions. Done. So here we're going to do that same protocol where we split it into two equations, but you'll quickly see when we do the first one, x plus 5 equals 0. There's not really a point to do a second equation because you negate 0, it's still 0. So there's only going to be one solution here. We're going to subtract by 5 on both sides, and we get x equals -5. Boom. For the following exercise, solve the equation by identifying the quadratic form. Use a substitute variable and find all real solutions by factoring. So here we can, it sort of looks like it could be factorable. The way we're going to do it by substitution is I'm going to say x squared equals y. So check it out. Then x to the fourth is simply y squared. 10x squared is simply 10y, right? Because y is x squared plus 9. And now I can factor like a typical quadratic. So we're going to say what multiplies to +9 adds to -10. That's going to be -1 and -9. So my two solutions are going to be what makes this go to 0, y equals 1, and what makes this go to 0, y equals 9. But again, that's solving for y. Now I need to solve for x. So I'm plugging these back into my original equation. So first I know that x squared equals y, which is 1. So boom. So now I can solve for x here, take the square root of both sides, and we get x equals plus or minus 1. So I'll say 1 and -1. And then we can do the same thing here, plug it in 9 for y. So we get x squared equals, x squared equals 9. Take the square root of both sides, and x equals plus or minus 3. So we got two more solutions, 3 and -3. These are the 4 solutions. Boom, done. Here they've kind of given us an indication of what we should be substituting for y because they put it in parentheses, which is cool. So I'm going to set y equal to x squared minus 1, and I can rewrite this. So it's y squared, right, plus just a little y by itself minus 12 equals 0. And now we can factor this. Boom, boom. What multiplies to -12 and adds to 1? That will be +4 and -3. So now we got our values here. We know that y equals whatever zeros this out, which would be -4, and y equals what zeros this out, which is +3. Now we're going to plug these values back in up here into this equation and solve for x. So we've got -4 equals x squared minus 1. We're going to add 1 to both sides. Boom, boom. And we get x squared equals -3. All right. Now right here, you should be able to see that this is not going to give us a legitimate real solution. This is going to give us an imaginary solution because if you take a square root of a negative, it's going to have I in the mix. So we're going to ignore this solution. Now I'm going to plug in +3 into that equation and see if we get a legitimate solution. So 3 equals x squared minus 1. Add 1 to both sides. Boom, boom. X squared equals 4. Take the square root. The square root of 4 is both 2 and -2. Those are the solutions. Done. For this one, I'm going to set x minus 3 equal to y. So I'm going to replace that with y squared minus 4 equals 0. Now, this is a nice difference of squares, so I can factor it to be y minus 2, y plus 2 equals 0, which gives me two solutions where this zeroes out, which is 2, and this one, which is -2. Now I'm going to plug these values in for y up here so we can get our x values. So x minus 3 equals 2. Add 3 to both sides, and we get x equals 5. Over here, we can say x minus 3 equals -2. And again, we're going to add 3 to both sides. Boom, boom. And that's going to give us x equals 1. So my two solutions are 5, 1, boom, done. So here what we're doing is we're taking the square root of something that is being squared. So it's almost like these two are going to cancel out, right? And so we're left with this equation of absolute value of x equals x. Well, guess what? Remember, this is the positive purifier. So for example, if I put a -5 into x, the right side will become 5, the left side will become -5. Well, that doesn't work. That's not true. So for any negative values, this will not work. But if I plug in 0 or any positive values for x, this is going to be a true equation, right? 5 equals absolute value of 5. 25 equals absolute value of 25. So the solution set for this is all values greater than or equal to 0. Done. So for this one, I'm going to start by splitting it into two equations. So we have the first where it simply equals 12, and then the second where this whole expression equals -12. So I'll do that down here. All right, now I'm going to solve this one. I'm going to subtract 12 from both sides, and I got x squared plus 2x minus 48, right? -36 minus 12 is -48. Then we're going to factor. What multiplies to -48 adds to +2. That's +8 and negative 6. So my two solutions here are going to be where this zeroes out at negative 8 and where this zeroes out at 6. We've also got this situation, so I'm going to add 12 to both sides, and I got x squared plus 2x. Negative 36 plus 12 is negative 24, and that equals 0. Then I'm going to factor what multiplies to negative 24 and adds to positive 2. That's positive 6 and negative 4. So that gives me a solution where this zeroes out of negative 6 and positive 4. So my solutions for x are negative 8, negative 6, 4, and 6. Boom, done. For the following exercises, use the model for the period of a pendulum t such that t equals this equation where the length of the pendulum is L, acceleration due to gravity is g. So it says if the gravity is 32 feet per second squared, so we're going to plug in 32 for g, and the period equals 1 second, and again, period is t, find the length. So we're plugging and chugging. So 1 period equals 2 pi times the square root of length, which is what we're solving for, over 32, and begin. So first I'm going to divide both sides by 2 pi, so I have 1 over 2 pi equals the square root of L over 32. Then I'm going to square both sides like so, right? And that's going to get rid of the square root. Now I have L over 32 equals 1 over 2 pi squared. Last but not least, I'm going to multiply by 32. So I've got 32 times 1 over 2 pi squared gives us the length. So now I'm going to use a calculator. And again, we're going to get this value in feet because we're using a value of gravity in feet. So we'll have to make the conversion to inches afterwards. So I've got 1 divided by 2 pi. And that gives us this value, and then we square it, and then we multiply that by 32. So again, this is in feet. To convert it to inches, I'm going to multiply this by 12, and we get 9.72. So to the nearest inch would be 10 inches. So 10 inches is the winner. Done. For the following exercises, use a model for body surface area BSA such that BSA equals this whole thing, where W is weight in kilograms and H is height in centimeters. So we're trying to find the weight of 177 centimeter male to the nearest kilogram. So we're trying to find W. Height we're given here as 177, and that height's meant to be in centimeters, so we're good to go. And then this is over 3,600, taking the square root of that, and that equals BSA of 2.1. So I'm going to plug in 2.1 here, and then we solve. So first I'm going to square both sides. Now, when I square 2.1, I have that one memorized. It's 4.41, and that equals, now when you square this, everything that comes out, so we have 177. I'm going to change the order, W over 3,600. Then I'm going to multiply both sides by 3,600, so 4.41 times 3,600 equals 177. W, last but not least, we'll divide by 177. And we'll get our value for W. Again, we want it to be to the nearest kilogram, so we're going to use a calculator. So we got 4.41 times 3,600 equals that, divided by 177. And we're rounding to the nearest unit, so we round up to 90. So the answer is 90 kilograms. Boom, done. I hope you guys enjoyed this video, and if you did, please click that like button. And if you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.